Let's step it up a gear with gears. What's up? I'm Jonathan and welcome to Maker Tales, where I'm sharing my maker journey to help you go further in yours. So don't forget to subscribe and hit that little bell icon to never miss an opportunity to keep making. Gears are amazing to add to any type of mechanism. However, they are quite tricky to understand as they fundamentally don't work with diameter-based calculations easily. Meaning that I should probably give you a small warning that this video is all about a formula to help us understand gears. To start off with, I'll be using Rhino 3D once again. However, the concepts in this video are transferable to any vector-based editing program, be it Inkscape or Illustrator. If you have not watched the previous videos in this series, I would strongly advise you do so, as I will not be recovering topics such as laser curve, joints, and what a sandwich mechanism is. Jumping straight into it, I prefer to use a paid program by Matthias Wandel to create my gears, which, by the way, if you want to get much deeper into gears, I suggest you take a look at his YouTube videos. But for the sakes of this video and accessibility, I will be using a free gear generator linked in the description. Please keep in mind that this gear generator has lots of limitations due to not being able to fiddle with a mountain of gear settings, but this free option is very useful to us and it has the ability to create a rake gear which many online free gear generators do not have. Anyway, with that said, here is where we left off with our last design. As you can see, we have the perfect space for a little gear here in the middle to interact with a rake gear on the fingers. Measuring this space, we get a diameter of 20mm, which is the diameter of a gear that we want. Let's head over to the online generator and figure this out. Now, if you have played around with the idea of gears before, you may have gotten this far, and then realized diameter and gears don't work well together. I know when I first found this, I was stumped on how to turn a desired diameter into a gear. So let's dip our toes into the endless rabbit hole that is gears. Getting right to the point on how to turn a desired diameter into a gear, short answer, you don't. Gears aren't inherently calculated to work with a set diameter. To solve this problem, we need to understand the building blocks of a gear. Simplifying a gear to some of its purest elements, it has two numbers: circular pitch and tooth count. Engineers, I'm sorry, I know this is a way oversimplification. In its simplest form, circular pitch is the distance between each gear tooth, which is also known as a cog. Tooth count is how many cogs are on a single gear. By multiplying the circular pitch with the tooth count, you get the pitch circle circumference. This pitch circle circumference is our connection point from our desired diameter to a gear. So just before we go and work through this to create our gear, just a small reminder that diameter times pi equals a circle's circumference. So back to our online gear generator. Let's set wheel 1 tooth count to 0, as this will generate a rake gear for us. From here, let's set the tooth count of the gear. This can be a little bit of trial and error with this free online generator. Plus, if you want a set amount of movement you want to achieve per gear tooth while a gear moves, there is a lot more math to go through that I quite frankly don't know yet. So, as this is relatively unimportant for our project and I don't want this generator to break on me, I'm going to set the wheel 2 tooth count to 10. So from here, now we have two of our numbers, our tooth count of 10 and our circumference, which is 20mm divided by pi, which is 62.8319. So to set our circular pitch, it's our circumference divided by our tooth count, which will come to 6.28319. Let's add that to the generator. Also, let's just quickly touch on pressure angle. Extremely simplified, this is how smooth your gear will feel. Feel free to play around with it. I would not really advise going over 30 though. Also, here is the caveat of gears. Gears, generally speaking, will only mesh well with other gears that have the same pressure angle and circular pitch. This is very important if you're going to be making a project with lots of gears, so keep that in mind. Lastly, just be mindful of the clearance and backlash. You can read what they do. I'll be leaving these at their defaults for now. Hit update and there you should have a gear and rake to be able to work with. If you zoom in, you can see it's all a little jaggedy. To smooth this out, in the settings below, change the 3 to 30. This will increase the curve resolution. Now that we have the gear that we want to generate, let's click generate, then download DXF and bring it into our vector editor. So we have our gear, rake, and where we left off. Now let's bring it all together. First off, I'm going to add a few construction lines, mainly where the outside edge of my box is and the center lines to get a center point. Let's think through what our new box lid would need. Fundamentally, what we're doing is removing all of our sliders for one top rotational movement. Well, in that case, we no longer need our UI layer as it is, so we will be making a whole new one. So let's remove our slider knobs. And looking just the top layer, we no longer need our pass-through holes either, so let's remove those. Now we should have something that looks a little like this. Now let's grab our gear and rake and place it in. Don't move the gear and the rake apart, as currently they are the right distance apart from one another. However, nothing is stopping us from trimming the unnecessary parts. And remember that this distance from one another is set in the generation itself. For me, it was 0.05. Once again, to work smart and not hard, let's remove the rest of the fingers to only edit one finger to then copy our changes that we are going to make. I am going to be placing one more construction line, which will let me know where another finger would be. If we place a copy of our gear in the center, we can see our current finger is just not long enough to add our rake gear to the finger. To fix this, let's extend our finger as far to the left as possible, keeping in mind that we need 4mm for the movement of the finger. With our finger extended, let's now implement our rake gear to the finger. Before I go on, I would like to take note of a small complication. Our gear does not have two-way symmetry, which means it's not symmetrical both on the X and Y, which in tail means that we need to now make two finger designs, which we can then copy to the other side of our lid. With that said, let's place our extra finger and gear racks in place. For the sake of visibility, I'll be turning off all the layers apart from the mech layer while I'm adding these rake gears to the fingers. While I add these rake gears to the fingers, I'm going to ignore the rake cogs that I don't think will be used in the full motion of the mechanism. With that done and bringing all the layers back, you should have something that looks like this. To make sure our mech layer works smoothly, we need to either add one long or two short guide rails to each finger. This will make sure that they don't rotate, plus they're going to limit the motion as we have removed the top layer with the pass-through hole. Remember to make these guide rails as long as the full range of motion. Now with the rail guides in place, let's add holes in the bottom layer to add the rail pins. Let's duplicate our fingers and finish placing them to almost finish our mech layer. Now to finish things off, let's bring it all together by adding a cross pin through the gear. This will be held in place by a guide hole on the top and bottom layer. A cross pin is similar to a normal pin joint, except we interlock two pin joints together to make an X shape. Lastly, let's create some sort of way of twisting this cross pin on the UI layer. With the UI layer made, let's separate each layer to check it has all the bits we need. Lastly, let's create our pins, add our laser compensation along with any fillets, and then nest our laser design to get it ready to cut. Once you have laser cut, given it a quick hit with the sandpaper, mounted it all together, you're now able to change your current lid for your gear lid. This should be a smooth operation, opening and closing. Following the series so far, you now understand how to create a proper joint, how to do sliding mechanisms, and how to do geared mechanisms. Not only that, you understand what a sandwich mechanism is, and all of this will build up to be able for you to create your own 15-step puzzle box design. So not wanting to leave you with just the fundamentals, we're going to be going even further. We're going to cover mazes, ball bearings, and weighted locks. All of this will build up to building our own 7-step puzzle boxes and 15-step puzzle boxes. A big thank you to my patrons right here. You guys are awesome. And if you want to support me, the link is down in the description. Thanks for watching, Keep making and let the quest continue.